Welcome to Understanding Common DDL Statements. In this learning activity, you'll explore the Data Definition Language, DDL, including its three main commands: create, alter, and drop. Structured Query Language, SQL, is a standard programming language for communicating with relational databases. Data Definition Language, DDL, is a subset of SQL. DDL commands define the database's structure. Examples of DDL tasks include creating or deleting data tables, changing table structure, and adding or removing relationships between the tables. Create, alter, and drop are main DDL commands. DDL syntax varies depending on the Relational Database Management System implementation, so a command in Microsoft SQL Server may look different from the same command in MySQL Server. For this activity, you'll use Microsoft SQL Server syntax. The DDL create statement creates any database or database object. For example, this is how the create command is structured. This creates a table including its columns. The database name specifies the name of the database where we'll add the table. To set the current database, you can proceed create with this SQL command. Schema is a subset of the database. It allows you to group and apply security to logically related database objects. A database may contain one or multiple schemas. If we don't specify the schema name in the create command, the table is added to the default schema of DBO. The table name needs to be unique within the database schema. It also needs to be meaningful so anyone can easily understand what the table contains. Each column in the table has a data type precision and/or a scale. These attributes determine the kind of data stored in the column and the space it requires. For additional information about data types, see the learning activity Database Data Types. When you create a table, you can apply specific rules or constraints to the stored data. Any command to add, update, or delete the data in the table has to comply with these rules. If the command doesn't comply, the command will result in an error. Primary keys and foreign keys are key constraints. A primary key determines what column or columns will serve as a unique identifier for a record. Foreign keys define the relationships between the detail and the master table through their foreign and primary key columns. A not null constraint means the column has to have a value. It can't contain null values. We can create a table using our defined constraints. Let's create the language table using the create statement and make our language ID the primary key. Notice we've added a not null constraint on both columns to make sure that language ID always has a value so it can uniquely identify a record, and language always has a value so the record makes sense. If we didn't, we'd be storing a language with no name, and that wouldn't make sense. Constraints are rules, and you can name these rules. In our example, PK language constraint is named and it defines a language ID column as a primary key. The fact that a constraint has a name allows us to find it in the future in case we need to change or delete it. Let's assume we've designed the following relational database. It consists of two normalized tables. A student table that stores student demographic data, including their native language, and a lookup table called language for all possible native languages. Multiple students may have the same first language, and at the same time, individual students may have only one language they consider their native language. We need to create the student table and tie these two together with the master detail relationship using the primary foreign key pair. We created a language table earlier using the primary key language ID. The next step is to add a student table to our university database. It needs to contain a student ID column, which contains unique integer identifiers for each record and is used as a primary key. A first name column, which can't be empty and needs to store a student first name no longer than 30 Unicode characters long. Unicode characters will come in handy if students have non-ASCII characters in their names, such as names in Russian or Japanese. A last name column, which also can't be empty, and needs to store student last names no longer than 30 Unicode characters long. An address column, which may be empty but can't be longer than 50 characters. A DOB column, which stores the student's date of birth and won't contain any nulls. An active as a flag column, which stores either 0 for false or 1 for true to indicate if a record is active. An SSN column, which contains a 9-character long social security number. A GPA column, which is a decimal column with a precision of 4 and scale of 2. A gender column, which may be empty but can only contain up to 1 character. And a language ID column, which is an integer column. This keyed column won't be null. Language ID is a foreign key which refers to the language ID primary key in the language table. The following commands create the student table according to our specific requirements. In addition to databases and tables, the create command also generates database table indexes. An index is a special data structure that speeds up data retrieval from the table. For example, an index on the student last name column in the student table speeds up searching by student last name. This illustrates how we add an index to the last name column. IX student last name is the name we're providing for our index in the DBO student table. We indicated what column we're adding the index to in parentheses and indicated we want the index stored in ascending order. The alter command modifies the structure of existing database entities. You can apply this command to these types of alterations: adding or deleting a column in the existing table, modifying data types as well as the column size, and adding, modifying, or removing a constraint in the table. Let's say we need to add a column named Program to the student table. This column covers the student's degree program such as computer science, nursing, or welding. We use this alter statement to add the program column to the student table. If we need to change the program column data type, we can alter the column using the alter column command. We use alter table with a drop clause to delete the program column from the student table. Alter table is used to add or modify a primary key constraint. It's important to note that before adding a primary key, we need to make sure the key column already has a constraint, not null. To add a primary key constraint named pkStudent to the student table, we'd use this command. Similarly, alter table is used to add or modify a foreign key constraint. To add a foreign key constraint named fkStudentLanguage to the student table, we would use the following syntax. In this statement, the language ID column is the foreign key of the student table. This foreign key column references the language ID column in the language table. The drop statement deletes a database or database object. Because this syntax is fairly straightforward, you have to be very careful using it. You can't recover the contents once you've run this statement. This is the general syntax to drop an object. First, determine the database in which the object is contained. Then use the drop command followed by the type of object, and depending on the type, further location information may be needed. You'd use this syntax to delete an index named IX student last name stored in the DBO student table. This command deletes a primary key constraint. We'd use this command to drop a foreign key constraint. This syntax is used to delete the DBO student table. And finally, to delete a database named university, you'd use this syntax. Remember, the master database is where databases are created and stored. Congratulations, you've completed understanding common DDL statements.